Welcome back, Physical Science 20. Hopefully you had a chance to do at least one of these practice questions and to see if you were able to do that two-step conversion. Now we'll look at just adding one extra thing to that two-step conversion. Possibly you're dealing with a compound and you want to figure out how many individual atoms are in that compound. So each molecular compound has a unique chemical formula which gives the exact number of atoms of each element. Therefore, if the number of molecules is known, then you can figure out the number of atoms of each element present. So for example, in one molecule of water, you know that there's 2 atoms of hydrogen and 1 atom of oxygen. Okay? Or if you had, so you know it's a 1:1:2 ratio here. If we had 10 molecules of water, you'd have 10 atoms of oxygen and 20 atoms of hydrogen because of how water molecule consists, what it consists of. 2 hydrogen for every 1 oxygen. Okay. Similarly, if we look at a aluminum sulfate compound, for every, now aluminum is a metal, SO4, those are all nonmetals, so that's not an atom, it's not a molecule, it's referred to as a formula unit of aluminum sulfate. We use that for ionic compounds. So for every 1 formula unit of aluminum sulfate, there are 2 aluminum ions and 3 SO4 ions or sulfate ions. Okay, so if we look at this chart, for every 1 formula unit, there's 2 aluminums, 3 sulfates. If I had 10, of course I'd have double, 20 aluminums, and then of course triple, 30 sulfate ions, because for every one of these there's 2 and there's 3. Double, triple, they're always a multiplying effect. If I had 2 million of these aluminum sulfates, I would have, let's see, times 2 is 4 million aluminums, or times 3, 6 million. If I had 1 mole, which really is this number here, 6.2 times 10 to the 23rd, doubling that, I'd have 1.204 times 10 to the 24 aluminum ions, or multiply that by 3, 1.806 times 10 to the 24 sulfate ions. Okay, so there you can see the relationship there. It all depends upon what the formula is. So if I look at this, the sample question here. Benzaldehyde C6H5CHO is a compound used to give prepared foods an almond flavor. Find the number of carbon, hydrogen, oxygen atoms in a 26.5 grams sample of this. So the rationale here would be to go from grams to moles to molecules. So figure out first how many molecules of this we have, and then from there we can use the formula to determine how many atoms of carbon, how many atoms of hydrogen, and how many atoms of oxygen are present. Okay, so this part here is similar to what we just did. Grams to moles, moles to molecule, simply that two-step conversion going from here to here. Okay, so of course that involves figuring out the molar mass of C6H5CHO. Of course, if you take a look here sneakily, there's actually 7 carbons, not just 6, because there's a carbon here. So 7 carbons, also 6 hydrogens, and 1 oxygen, because there's H5 and there's H, so there's a total of 6. So 106.13 grams per mole. So this first step here, what they did here, they break it down into 3 separate steps. Going from grams to moles, first of all, simply doing this, dividing by the grams, 1 mole on top, grams on the bottom, moles on top, 0.24969. So the problem with doing this in a bunch of little steps, you have to make sure you don't round off the answer, because you'll be introducing error because you're taking that number and doing something else to it. Okay, that's why I prefer doing everything in one big step, because you just run that through your calculator and then get your grand finale answer there. The next step, moles to molecules. Moles to molecules. Here is the equation right there, or their conversion factor, sorry. So multiply by 6.2 times 10 to the 23rd molecules over 1 mole, and we get 1.503 times 10 to the 23 molecules. So we're here. Now what you have to do here is to figure out for every 1 molecule, how many carbon atoms do you have, how many hydrogens, etc. And you can see we have 7 carbons, 6 hydrogens, 1 oxygen, because we had to find those numbers to figure out the molar mass initially. So our number of 1.503 times 10 to the 23, we're going to use that to figure out the number of carbons. For every 1 molecule of benzaldehyde, we have 7 atoms of carbon. So we just multiply by 7 over 1. For every 1 molecule, 7 atoms. And where I'm getting that conversion factor is from the formula itself. This part will be different for different questions because it depends upon what the formula is. For every one molecule, there's 6 plus 1, 7 carbons. 5 plus 1, 6 hydrogens, and 1 oxygen. So you can see 7, 6, and 1 from over there. So we end up with 1.05 times 10 to the 24 atoms of carbon, 9.02 times 10 to the 23 atoms of H, and 1.50 times 10 to the 23 atoms of O. And these, this last factor here is just from the formula. So what I'm going to do, we'll go through number 1 here, and if you need to, you could go through maybe number 2 and 3, and then we'll go through the assignment. So number 1, find the number of hydrogen and oxygen atoms present in 15 grams of hydrogen peroxide. And it says pure there, we're assuming that's all we have is hydrogen peroxide. So very similar scheme. We're going to go grams to moles, figure out how many molecules of hydrogen peroxide, and then from there use the formula to figure out how many H's and O's we have. So I did this on a separate paper because I could have done it over here, but it would have been too cluttered for the video. So if you want to copy it out here, if you think you can fit it, go ahead. Otherwise, you may want to use another piece of paper like I did. Okay, so hydrogen peroxide, you need to figure out the molar mass first of all. 2 hydrogens, 2 oxygens. So there we have it there, 34.02 grams per mole. So 15 grams, we're going from grams to moles. So of course there's our factor there, 1 mole over the grams, 1 mole over the molar mass grams. And then from there, moles to particles, or in this case we're dealing with molecules because H2O2. Hydrogen is considered a non-metal in this case. Multiply by 6.02 times 10 to the 23rd. Cancel the moles, and I end up with 2.65 times 10 to the 23 molecules of H2O2. I likely should have carried extra digits there, but I didn't. So, to figure out how many hydrogen atoms and oxygen atoms there are, the last thing we do here, again, it depends upon the formula. In 1 molecule or 1 formula unit, how many atoms of each are there? So we can see here that for every 1 H2O2 molecule, there are 2 atoms of H. For every 1 molecule of H2O2, there are 2 atoms of H. So this number just simply gets doubled. And as luck would have it, the ratio of oxygen is the same as well. For every 1 molecule of hydrogen, H2O2, we have 2 atoms of O. So we get the same answer there. So there you have it. Using the formula for that last conversion, when you know how many molecules or formula units you have, and you want to figure out how many individual atoms are present. Okay, there you have it. So that's a fairly big question. So you may want to try number 1 or number 3 yourself here before you go into the question. So again here, we're looking at, they mentioned this little formula here, but again, use this scheme. It's much easier. The number of atoms or ions in a sample of a compound equals the number of atoms or ions per molecule or formula unit times the molecules or formula units in the sample. And that's it. So the questions I would like you to do here, just the ones on the left-hand side all the way up to 5. So 1 to 5, and again, like I always mention, wherever they use the word amount, that really implies moles. Okay? Just kind of showing this here, milligrams, of course, there's 1,000 milligrams in the gram, so you'll have to change that to grams first of all, but otherwise, everything should be fairly similar to what we have just done. Okay, we'll see you again.